Well, welcome to this online revision session for AQA FP1, in which we will be looking at the June 2010 question 4, which is on reducing to a linear form. As you can see, we are given the fact there is a set of data related by the equation y equals ax squared plus b, where a and b are constants. And we're going to work through this problem to hopefully reduce it to a linear form. So the fact that we've been given that it's y equals ax squared plus b, we can replace x squared with big X, and then we have y equals ax plus b, where a will be the gradient and b will be the y-intercept of a straight line, assuming this data is of that form. So in part A, they ask you to firstly work out big X, where big X is equal to x squared, which is our substitution in here. So, fairly obvious what to do. Hopefully you'll get this part correct. Okay, so there we can see we've squared all the entries, and if we've done that correctly, we'll just be given 1 mark for doing that. Then it says on the diagram to draw the relationship of y against big X. And you can see we've got y on the vertical axis, big X on the horizontal axis, and so we've got to plot each of these values. So the first one is 4, 6, so it's 4, 6, so that's going to be there. Next one is 16, so 16 is there, and 10.5 will be there. And then we've got 36, so that's 36, 18, which takes us up to there. And then finally we've got 64, and it's 28, 28, so that's 30 there, so 28.2 is about there. And so you can see this forms a straight line, and so we could draw your line of best fit going through these 4 points. Now, I don't actually have a straight line drawer as an option here, so we'll just have to leave that to your imagination as to where that line will actually go. Again, it's 2 marks. 2 marks will be 1 point for plotting these points accurately, and then 1 mark for drawing in and showing the linear relationship. Next part then says use your graph to estimate to 2 significant figures the following: the value of x when y is 15, and then the values of a and b, bearing in mind that a and b, a is the gradient and b is the y-intercept. So first part then, find the value of x when y is 15. We can find the value of our graph at 15, and then read off an appropriate value. So 15 is the y value, so we come across and down to read off the x value, which is about 25 or 26, but that is the big X value. So for this part you get the big X value is approximately 26, so to find x we would then have to square root whatever the value is that you've taken off here. Okay, and I was really not totally sure. You will have a much better graph than me to be able to read off that value, whether it's 26 or maybe even 27 actually, looking at it now. So maybe that should be 27. Either way, your approximate value is going to be around 5.3. Okay, remembering to take the square root will give you a method mark for that part, and then you'll get an accuracy mark for the value that you obtain. Obtaining the y-intercept, the value of b, if you remember, because that's corresponding to this value in your equation. We just follow the line back, we would see that that is approximately 4.5. Then to obtain the gradient, well, you could calculate it between two of the points. Well, since you know that b is approximately 4.5, we could do the difference in x value over the difference in y value. So if we took that last point where x is 8, which gave you big X as being 64, and the y value is 28.2, we could do then that the gradient A would be over 64, because that's the horizontal distance, and the vertical distance would be 28.2 minus 4.5. And then we can calculate what value you get, and it's going to be somewhere between about 0.36 and 0.38, depending upon how accurately what value you've read off for your y-intercept, or depends on which pair of values you may have used along the line on the way. Okay, so if we put down 0.37, if you get a value between 0.36 and 0.38, you will get the marks for your accuracy there. So for stating the value of b, you get 1 mark, reading that off the graph. For an appropriate calculation for your gradient, and then an answer will give you the other 2 marks. Well, hopefully you found that solution helpful. For help with your maths revision, please go to the Further Maths Support Programme website.